Hello everyone. Can you guys hear me?
Yep.
Alright, so I guess we can start now. Let me just quickly share my screen to you guys. Alright. Welcome guys. Welcome to another session of Statistic for Machine Learning, AI and Data Science. This is Jaren Saima Rosa. I'm currently studying in Brack University and this is my third year. So without any further ado, let's get started. In today's session, we will be talking about Pearson Correlation Coefficient, which was left in the last session. Then we will talk about normal distribution. Then we will know what is Z score, Z table. Then we will understand what is standard normal distribution and how to convert the normal distribution to standard normal distribution. To know that, we will understand the standardization process. So let's get started. Firstly, let's start with Pearson correlation coefficient. So in the last session, we talked about covariance, right? So we were left with one problem that was in covariance. We weren't able to get the magnitude of the regression. We weren't able to get the we were able to get the direction, but we weren't able to get the magnitude that the how strong the relationship was between two or more variables. So to resolve that problem, now we have Pearson correlation coefficient. So let's get started. All right. So just that I said that the problem that we were facing that we weren't able to get the magnitude between two variables. So what is Pearson correlation coefficient all about? It is the measurement of the strength and the direction and the relation between two or more variables. So what does Pearson correlation coefficient is about? It tells us the measurement measurement of the strength and direction between two variables. In our daily life, we see many examples such that if one variable increases, another one decreases. For example, if you study more hours, you get better results. So in that case, the more hour you study, so and the result gets better. Then you can also say, um, suppose the price of Coca-Cola. So price of Coca-Cola has increased. So in that case, the demand of 7-Up will increase. All right, or it can work differently as well, right? So suppose if a vehicle increases its speed, you are more likely to reach the destination on time. That means the more speed your vehicle is having, you're more likely to reach your destination or time, or the distance gets smaller. So in Pearson correlation coefficient, we have three type of relation. One is positive linear relation. Then we have negative linear relationship, and then we have zero relationship. That means your two variable is not correlated at all. Zero relationship. All right. So to work with Pearson correlation coefficient, you have to keep some things in your mind very clearly. So firstly, that it works well with linear equation. It works well with linear equation. And to understand the magnitude very well, it converts the whole value from -1 to +1. Linear equation. And it to indicate the strength, it it takes a value between negative to +1. Alright. Now let's look at some examples so that we can understand it more clearly. If we talk about positive linear relationship, um, we can give an example such person's income increases with age. So in that case, when the age of a person is increasing, his or her income is also increasing. This is a very general case. Yes. Then in the negative relationship, we can also similarly we can give examples such the price of if the price of coffee increases, for that the demand of tea will also increase. In that case, the price of coffee will increase, so the demand of tea will also increase. So we can see the relationship between two variables that both are increasing at the same time, or we can see both one is increasing and at the same time another one is in decreasing. So by looking at the graph, we can understand if it is a positive linear relationship, or is it negative, or it doesn't have any relationship at all. So let's look at some graph. Suppose this is your data points, which are like this. And in this case, you can see you get a best fit line, right? So the scatter plots are very tightly around the line you are having. In this case, we can tell that it is having a positive correlation. And the value, Pearson's correlation coefficient's value, P, is almost +1. Then for, let's say, if your graph looks like something this, again, you have a best fit line where the data points is very near to the linear equation, right? So in this case, you can see this is a negative relationship. As the x increases, the y decreases, or the similar thing can happen as well. The y increases and the x decreases. And in this case, the x increases, y increases, or the x decreases, y decreases. Alright, so in this case, you can tell that it is a negative correlation, and the value of P is almost -1. So just like I told you that in Pearson correlation shape, you will find your value between -1 to +1, and by this range, you will understand how what is the magnitude between your two variables. For this reason, we have -1 to +1 to understand the relationship, to understand the magnitude or the strength between two variables. So let's see another example. Okay, let's say these are your data points and your polynomial goes something like this. Or yeah, so in this case you can say that there is no relationship, right? There is no relationship. We cannot visualize any relationship in this case. So in this case, you can say the P is 0, and this type of plot can be called as zero relationship. All right. Suppose again you are having a positive correlation, but now this time your data points are not as tightly around the line. Your data points are like this, but you can tell that uh, the line goes between the data point. So in that case, what can you say? In that case, you can say that this graph has a medium positive correlation shape. Medium positive correlation shape. And in this case, the value of your P is above 0.8 but below 1, because if it is 1 it will be this situation, but we are not talking about this situation. In this thing, the scatter plots are far away from line, not far away, but it's not also tightly around the line, right? Then similarly we can have another scenario where your suppose these are the data points and this is the line. You can say that it has a negative relationship, but it is the data points are since the data points are not tightly around the line, we can tell that it is small negative approximate. And in this case, your uh, Pearson value will be smaller than -0.5. All right, so this was for Pearson correlation coefficient. Do you have any question, guys? Just let me know if you have any question, or I can move forward. All right, moving forward. Now let's talk about normal distribution. Normal distribution. Okay, one thing that I forgot to tell you, that why Pearson correlation coefficient is so important. Suppose in one of your machine learning problem, you are solving a problem with linear regression, and in this case, if you don't know the relationship between two variables, you may predict a totally wrong value. So to avoid these cases, it is very important to know the relationship between the variables uh, which you are working with. All right, so normal distribution. Suppose we are taking the height of students of a classroom. So suppose this is a classroom and there are many students and we are taking the heights of students of a classroom. All right. Now we have different ranges from height. We have height from 4.5 to 6 feet, 6.5 inch, a bigger range of height. And now we want to draw a histogram on that. So suppose I'm drawing a histogram. Similarly, on this side, we're just taking random values and assuming that we have such values, alright? So these things are called bins. So let's say in this bin, we have students who have height from 6.5 to 7 feet, 6.5, 6 feet 5 inch to 7 feet, and in these bins we have lesser height, and the increase in these bins we have the height that are more than 7 feet. Okay, that is bit unrealistic, but let's just take it. Let's just assume it. Alright, so suppose now I am thinning the bin, and the bin looks something like this, this, and it is repeatedly getting very thin, right? All these bins are getting thinner. Suppose I am thinning the bin, and yes, and then we are again doing it, and this at some point by thinning the bins, we will get to the point where we don't have such curve, we don't have such bar, we will have a smooth line, right? We will have a smooth line, and this type of this type of thing is called a distribution. Yes, it can be tilted toward left, or uh, the average value also can be tilted toward right. But in this case, we are thinking that yes, it is a very symmetric distribution, and this is the mean. Alright, so this is the distribution. And what do you understand by the normal distribution? Sorry. Okay, I know it is not symmetric, but let's just think it is symmetric, right? So in this case, suppose this is the mean. This is known as a normal distribution. So what uh, it is also known as Gaussian distribution. It looks some sort of bell, right? So many people call it bell-shaped curve. All right. So from this picture, what we understand, that suppose, yeah, that I just said we use the height of a classroom, right? The students of height. So short, tall, and people with average height. By looking at this, we understand that the that it is relatively rare to see someone this short, and then also we also understand that it is also relatively rare to see someone very tall in the classroom. Most of the students have average height. Suppose the average height is, let's say, it is um, 70 inches. Let's say it is 70 inches, the average height, if you measure it in the inches. So by looking at this thing, we understand that this in the classroom there are very few short people, or in the classroom there are very few tall people. The average people have height which are around 70 inches. They may have height which is 60 inches or 80 inches, 90, so on and so forth. Now, if we have two different plot to make you understand this thing more nicely, suppose this is your normal distribution and this is your, again, this is your normal distribution and this is the mean, and in this case, this is the mean. By looking at this, distribution, we understand that the values are well spreaded. What do you understand? The values are well spreaded. And by looking at this distribution, we understand that the most of the people are having height, or whatever the variable is we're talking about. Most of the people has height which are tightly concentrated around the mean. So the values are not well spread. We will have more values around the mean. It should get a bit taller. Okay, never mind. Values are tightly around the mean. Let's take an example. Let's say in this case the mean is 20 inches and 10, 30, and in this case suppose the mean is 70 inches, and let's write the other values as well. And in this case we are talking about the height. In this case we are talking about the height of men in general, height of men, and in this case we're talking about height of newborn babies, or just say kids. All right, height of babies. So you can see that we may have people, men, who have different a wide range of height, right? There are men with 50 inches of height. There are men who have 80, who have height of 80 inches. But will you see a kid who has 40 inches of height? It is not common. It's not common, right? So in this case, the most of the kid will have height around 20 inches. So in this case, the probability of kids having height of 20 inches is higher. But in this case, this should be a little shorter, right? Because the wider the range is, the shorter the distribution looks. So let's just erase it. All right. And in this case, you will understand that most of the kids have height of 20 inches, and men have a wide variety of heights. So just a second, please. Just a second. Mm, right. Okay. So whereas so the conclusion that we must have from this thing, that is, in this case, we can see that the if your distribution has more width, just a second, guys, it's giving me some technical issue. Just a second, please. All right. Okay. Thanks for the patience. From this discussion, what is the takeaway? The takeaway is, if the width of your distribution is greater, you will have a distribution which looks shorter. You see, the range is very wide, and if your width is not as big as it, the distribution will be taller. So in this case, the distribution will be taller if your width is short. Alright, so by the width, what do you understand? It's talking about the standard deviation. So in this case, the standard deviation was very short, though we didn't discuss it. The standard deviation must be very short, that the kid must have 20 inches, and then some kid may have 22 inches, then the some kid also may have 18 inches of height. But in this case, you can see that the standard deviation, this is, suppose this is one standard deviation, then this is two standard deviation. We have already talked about it, right? We have talked about it in the previous sessions. In this case, the value of standard deviation is bigger, so the distribution looks very fat, or the distribution is well spreaded. But in this case, the value of standard deviation is very small, so the distribution looks very taller, or tightly concentrated up in the mean. All right, so the width of the curve is defined by the standard deviation, and babies have the relatively small standard deviation comparatively to the men. All right. So this was about normal distribution. So the point that you should have in your mind, that the normal distribution must must be symmetrical. It may look like bell shaped, and you may have different types of distribution. Some may look thin, some may look a bit fat, but we can convert all them into a similar looking distribution. and the process of it is known as standardization. So suppose, just like the previous example, your sum standard deviation, your sum distribution was looking like this. Your sum distribution were looking like this. Then you also may have some distribution which looks like this. Different looking distributions. But you want all of them to look alike. To, for what? For your calculation to be more simple, you convert them all which to a distribution which has a mean of 0 and standard deviation of 1, and it exactly looks like a bell shift. So what is the difference between standard normal, and this is known as standard normal distribution or SND, and what is the difference between normal distribution and standard normal distribution? In standard normal distribution, your population mean must be 0 and your standard deviation should be 1. But in that case, you were having different values, right? Such this case, your mean was 20. In this case, your mean was 70. And your standard deviation was what? 10. And also in this case, your standard deviation was 10. So converting standard deviation and mean to a specific number, we are getting a new distribution which is known as standard normal distribution. And the process by which we are converting the normal distribution to the standard normal distribution is known standardization. So what is standardization? Standardization is the process by which normal distribution is converted to standard normal distribution. So this process is known as standardization. Okay, so far, do you guys have any question? If not, I can move forward. Okay, I think I am good to go. All right. Okay, one thing that I forgot to mention, that is the empirical rule or 68, 95, 99.7 rule, which is applied on the normal distribution. Let's just talk about it shortly, right? Then after that, we will talk about the standard normal distribution. So let's talk about the empirical rule, also known as 68, 95, 99.7 rule. Okay. So what does actually mean? Suppose this is your normal distribution. This is your mean. This is your population mean. And you have one standard deviation to the right. Then you have two standard deviation to the right. And then you have three standard deviation to the right. Then you are just distributing it with minus 2 standard deviation, which means 2 standard deviation to the left. Then you have 3 standard deviation to the left. Alright, suppose this is your distribution. This can be a distribution of any normal distributed values, such as, what are the normally distributed values? Age is a normal distribution. Height is a normal distribution. Weight is a normal distribution. Then there are a lot of things that are used daily, and these are the normal distribution because we can have a wide range of values, but most of the values concentrated around the center. So This examples falls under the normal distribution. So what does this empirical rule means? If we take one standard deviation, which is okay, sorry, I just wrote a bit wrong information here. This should be -2 and this should be -3 standard distribution. So what's happening? Okay, let me take a different. Just a second, guys. Just a second. All right, we were here, right? Okay. So if we take this part, just a second, please. All right. So if we take one standard deviation away from the mean, which means this part, it tells that 68% of the total distribution lies here. It means 68 of the total distribution or the total data set we have lies in this range. Then if we take two standard deviation from the mean, which means this part, it gives us an idea that 95% data lies in this part. So in this area, 95% of data of the dataset lies in this portion. And if we take three standard deviation from the mean, which means this part, this gives us a rough idea that 99.7% of the distribution or the dataset lies in this portion. So in this portion, 99.7% of the data is here. Guys, do you understand what I'm saying, or you want me to explain this thing a bit more? It would be very much appreciated if you say if you're understanding it. It's all good. All right. Uh, so this is known as empirical rule. Let's do some quick maths to understand this topic bit well. Okay. So suppose you are given a standard deviation of 10 and standard deviation of 10 and your data set and your distribution looks something like this and the mean is 70 and your distribution looks something like and your distribution looks something like this. Since the mean is 70, we are just going to give the middle part here, which is mean equal to 70. And since the standard deviation is 10, that means the one standard deviation to the right will be 60, and then the second standard deviation to the 60, not 60, it will be 80 because it will increase 10 more, then 2 standard deviation. So one standard deviation to the right means mean plus one standard deviation, which gives us 70 plus 10 equal to 80. So this is how we get the values. Then 2 standard deviation from the right. So in this part we will have 90, and 3 standard deviation to the right we will have 100. It is increasing by 10. And if we get the values here, one standard deviation to the left, which means one standard deviation to the left, how we calculate it? It is population mean minus one standard deviation. And what is the value of standard deviation? It is 10. So 70 minus 10 is 60. So it will be 60 and 50 and 40. Alright. So the question is approximately what area is contained between the area of 70 and 90. So it is asking us that what is the area between 70 and 90. So from the distribution we can tell that we must get the area between this part. What is the percentage of data that lies in this area? Okay, so from the empirical rule, we understood that two standard deviation from the two standard deviation from the mean gives us. So what is the two standard deviation from the mean? This is one standard deviation. This is positive one standard deviation. This is negative one standard deviation. So two standard deviation from the mean is this portion, right? I mean, if I use different color to make you understand more, this part to this part. So in this area, we know 95% of the values of dataset is in this area. What is it? 95 percentage of the dataset falls under this area, which is two standard deviation from the mean. Now, in my question, I am asked to find the value between 70 and 90. Can we not just divide the 95 percentage by 2 to get the values between 70 to 90? Because it is the half of this part, right? So if this part is 95 percentage, so this portion will have 95 percentage by 2 percentage of values in this area. So what is the value by 95 by 2? This is 47.5. So 47.5 percentage of the dataset lies in this area, which is one, not two standard deviation to the right. Am I clear in this part? Do you understand what I'm saying? All right. I think uh, we can talk about a different example to understand this part more clearly. Okay. Suppose this is your distribution over here. This is your mean. Your mean is 0, and uh, you are given your standard deviation is 1. So since your mean is 0 and your standard deviation 1, by 1 your number line will increase. So after 0 you have 1, 2, then you have 3, and then you have -1, -2, -3, correct? So what is your question? The question is find the area between -2 to and find the area between -2 and 1. So we are asked to find this area, right? We are asked to find this area, and we can see that if this is our mean and this is one standard deviation to the right, and this is -2 2 standard deviation to the left, or -2 standard deviation, you can also tell it like this. So you have to find the value between this area. You have to find the percentage. For this case, what you will do, you know from empirical rule that from one standard deviation to the mean, 68 percentage value lies. So in this case, this is one standard deviation to the mean, right? And in this portion, in this area, 68 percentage of values lies here. You know that, right? And this is 2 standard deviation from the mean, this area. And if you also take this value, if I use a different color, and this whole part, in this whole portion we find 95 percentage of the distribution. So to find this distribution, the distribution between -2 to 1, what we can do, we have to find this part, right? What we can do, we can firstly, and this is the population mean, we can firstly divide the 68 percentage. So we get this portion. If we divide the 68 percentage by 2, we will have this portion, right? And after that, if I divide 95 percentage by 2, which means this is the whole 95 percentage, and if I divide it by 2, that means this portion. So in total, am I not getting the values between -2 to 1? So what can I do to get this? I can divide 68 by 2 plus 95 by 2. So in total, 34 plus 47.5. So in total, 81.5 percentage of the value of the total distribution lies in this area. So I think we are done with the empirical rule. We have just practiced a few problems from here. Now we can move to we can move to another topic. Okay, which is Z score. So I just talked that how can we change the normal distribution to the standard normal distribution, right? And in this case, the mean will always be 0 and it will increase by 1. The standard deviation will always be what? The standard deviation will always be 1. So in this case, this should this should be the general value. This should be the general case of any standard normal distribution. So the standard normal distribution looks like this because we are converting the normal distribution to the standard normal distribution form, and it will always have the mean as 0 and standard deviation as 1. Now let's practice some math and let's understand how can we convert a normal distribution to a standard normal distribution, by which we can do it. Okay, so let's do it in this portion. Since we need the z table, all right. So firstly, I just told you that to find the standard normal distribution, we have to find the z-score, and then by finding the z-score, we will substitute each of the observation of the normal distribution, and we will find a new distribution which is known as standard normal distribution. Now let's see what is the formula of z-score. The formula of z-score is x, which is known as observation. Suppose in your data set you have 10, 20, 30, 40. Each of these values are the observations, minus population mean by population standard deviation. This is the formula for z-score. By using z-score, we will get the value of standard normal distribution. So let's see an example to understand this topic more clearly. Suppose we gathered some data from last year's midterm examination. Let's say statistic examination. So we got some data from the examination of statistic happened in last year, and we found out that a normal distribution, we found a normal distribution with mean of 60 and the standard deviation here is 10. So from this value, can't we draw a normal distribution? Suppose these are the scores of the statistic examination that happened last year. So let's just draw something. Since the mean is 60, so the average people got 60 marks and the standard deviation is 10. So one standard deviation to the right, two standard deviation to the right, three standard deviation to the right, one standard deviation to the left, two standard deviation to the left, and three standard deviation to the left. Correct? As you can see, this distribution, the population mean is not 0, and we also don't have the standard deviation as 1. So to convert this to a standard, this is a normal distribution, and to convert this to a standard normal distribution, we will use z-score. So since x is observation and since the uh, population mean is 60 and standard deviation is 1, so 10, in this case 10 will be here. So if I firstly, let's find the mean in this case. Okay, In this case, this was the mean. So if I plug in 60 in here, what will I get? 60 minus 60 by 10, which is what? 0 by 10 equal to 0. So I am getting the mean as 0, right? First condition tick marked. Then after that, if I plug in 70 over here, 70 minus 60 by 10 is equal to 10 by 10 equal to 1. So 1 over here. And then similarly, if I plug in 80 over here, we will get 2. If we plug in 90 over here, we will get 3. And for the left side, if we plug in 50 over here, am I not getting negative 1? 50 minus 60 by 10 equal to negative 1. So after plugging 50, 40 and 30, we are getting minus 1, minus 2 and minus 3. And here you go. We have our standard normal distribution. So we can convert any normal distribution to standard normal distribution by the z-score. So this is the z-score. Okay. So you've just saw that this is the z-score. Now let's solve some question. All right. Suppose you are told to find the proportion of students who scored less than 49 on the exam. So what are you supposed to do? You have to find what is the proportion, what is the proportion of students scoring less than 49 on exam. So you can write your problem statement like this, because in this case you are going to find those values, or you may find the percentage of people who scored below 49. So the observation X, I mean these values must be less than 49, right? And you see, if I want to find the thing over here, 49 falls something between here, right? So you have to find this area, or the percentage of people who scored below 49. You have to find it. Now you're going to work with z-score, right? So you have to do the thing wholly on this distribution. So firstly, what are you going to do? You're going to find the z-score of for this value. For this value, the z-score will be 49 minus 60, as in the previous question we found the mean 60 and the standard deviation was 10. And if you do so, you will get, just a second, let me just calculate it. 49 minus 60 by 10 is minus 1.1, right? Now here comes the thing, minus 1.1. So if you find minus 1.1, which is somewhere between this part, so in the standard normal distribution, you should find this area, or percentage of people who scored less than 49. You have to find it. And how you will find it? To find the area under the curve, we have the table. So you see this these tables, which look a bit scary, but hold on guys, I'm making these things simpler to you. So this is the right Z table, and this is the left Z table. So you will firstly find your the Z score, and after doing that, you will incorporate your value. For this case, you find minus 1.1 on this table, and then you will try to find the area. By area, what do I mean? Like in this case, we are trying to find this part, right? So in that Z table, after standardizing a normal distribution to standard normal distribution, we can find the area, because all of the values are from minus 3 to 3. So we must find the value over here. As you can see, the Z score is from here 3 and 3.4 to minus 3.4. For this reason, we converted it to the Z score, and after having the Z score, you will getting a smaller value which is in the table to find the area. Uh, if it seems a bit overwhelming, hold on, I'm making things easier to you. You have minus 1.1, right? So let's find minus 1.1. So to find minus 1.1, you will use this table. Firstly, you have to find in this part, firstly you have to find minus 1.1. You see, you go below, and you found minus 1.1. Do we have anything after minus 1.1? No, so we have 0, right? So in this case, this should be our value. This is the thing, this is the area that we are wanting, which is 1.357. So we were finding the Z score, which was below 1.1, and we got 0.1357, which will tell us about the area. Now, if I 1.357 into 100, now if we multiply it to 100, we are getting 13.57 percentage. What does it mean, guys? It means that the 35.57 percentage of students who attended the statistic exams got below 49, and this percentage is 13.75. This is the percentage of people who got below 49. So you see, if we did not convert it into the standard normal distribution, we wouldn't be able to find out the percentage so easily, right? Now if we look into another example, alright, now if we move to another example, suppose you study in XYZ university, and it was found that it was normally distributed with a mean of height of 5.5 feet and standard deviation. So the mean was 5.5 in XYZ universities, and the standard deviation was 0.5 feet. So you may say most of the students in XYZ university have a height of 5.5 feet. So what is your question? Your question is telling what proportion of students are of students are between area, sorry, between 5.81 and 5.6 and 6.3 feet tall. So in the XYZ university, you have to find the proportion, or also you can find the percentage by just simply multiplying 100. You have to find the percentage of student that has a height of 5.81 in 5.81 feet to 6.3 feet, right? So before that, let's draw the normal distribution for this. And for drawing the normal distribution, we should have the mean, which we already have, which is 5.5. And now the other values. One standard deviation to the right is 5.5 plus 0.5, which is 6. And the second standard deviation to the right is 6.5, and then again adding 0.5, which is 7. And in this case, this is your mean. Sorry, it is looking asymmetric, but it should look as some should look symmetric. Okay, this is the main value. Okay, anyways, this is the normal distribution of your question, but we are we will solve this problem by converting it to the standard normal deviation, right? Standard normal distribution. So it is also okay if I don't draw the distribution for this table, because by incorporating these values to the z score, you will automatically find the standard normal distributions uh, information that you need to solve this question. So in this question, 5.81, which falls somewhere between here, and 6.3, which falls somewhere between here, you have to find this value, don't you? Why I'm so bad with this graphics tab. Just bear with me, guys. Okay. I mean, you get my point, right? You get the picture. You have to find this area to find the people who are in between this height. So just like we did in the previous thing, firstly, let's find the z score. In this case, the x is what? Firstly, the x is 5.81, and the population mean is 5.5. The standard deviation is 0.5. So we will have a value for this. And again, when we take this value as observation, which I mean by x, 6.3 will be here. 6.3 minus 5.5 by 0.5, and after calculating these values, you get 0.62, and for this case you get 1.6. Now since you have your z score, what you have to do, you have to find the values, the area from the z table, right? So in this case, firstly let's find for 0.62. Let's get to the z score. Here we have to find 0.62. All right, so in this case, you see this is 0.6, and after 6 we should have 2. So this is our value that we are looking for, which is 0.7324. So in this case, this is 0.7, for this we are getting the area is 0.7324. All right. Okay, guys, if I just shortly tell you what does it mean. Uh, okay, it was for 5.81, right? For this part. So by this thing, By leaving this, having this value, it means that this area, this whole area is having a proportion of 0.7324, or you can also find it in the percentage. And then you will also find the area for 6.3, so it will be the whole area, right? I mean this part also. Then if you subtract this area that you will have from this to this, won't you be able to get this area? If you are overwhelmed, let me just do it for you. So then we have to find 1.6. Then let's again go to the z table, the horrific z table. It looks very ugly, right? 1.6, and here is 1.6. It was just 1.6, right? So this is your value, which is 0.9452. So by this, what do you mean? What do you understand? That this whole area from 0.63, this area is 0.9452. Sorry for the messy handwriting. Now, if we just subtract this value, these are the areas, right? Aren't we be able to get this value? So if we subtract it, what are we going to do? We are going to subtract it. So just write it in a formal manner. 0.9452 minus 0.7324, you will get 0.2128, and 0.2128 into 100 is equal to 21%, 21.28 percentage. So what do we understand? That the 21.28 percentage of students from XY university has a height between 5 point, what was the question, 5.81 to 6.3 feet of height. So this area is 21.28 percentage. So we can practice more example if you want. Please tell me, should I move on, or should I conclude the session over here, since we are doing the session for 1 hour and 20 minutes. Should I show you another example, or I should conclude here? Did you understand what was the topic, since the last topic was a bit overwhelming? Are you guys all clear, or I should show you another example? Please let me know. Um, okay. Since we have already done these topics, I think you guys are clear till now. Um, guys, you can ask any question if you are confused about any topic. I may explain it more. Alright, so I may conclude the session over here. Thank you so much, everyone, for staying this long. Your patience are very much appreciated. We will take our next session in the next few days. I will let you know in my socials, from my socials. And thank you very much, everyone, for staying. So thank you, everyone. And if you have any question, you can totally knock at my socials, at my Facebook or my LinkedIn, if you have any question related to the session. Thank you, everyone. Bye bye.